Hello everyone. Today we are going to discuss about the case study on eigenvalues and eigenvectors via design thinking. Let us see the population dynamics with the Leslie matrix. Let us introduction to type 5 problem and design thinking. Here the eigenvalues and eigenvectors satisfying the equation A V equal to lambda V for square matrix A. And type 5 problem involve advanced applications such as population dynamics where eigenvalues represent the growth and growth rates, eigenvectors represent the stable distribution. So that in design thinking stages, empathize, define, ideate, prototype, test. The case study is using 3 by 3 Leslie matrix to model population growth across the three age groups. Empathize. A user, that is ecologist studying population dynamics of species. Context. The model population growth across three age group. Juvenile, adult, yearly to predict long-term trends. The needs to determine the population growth rate and stable age distribution to inform conservation strategies. The main goal is using eigenvalues to analyze the Leslie matrix. Define. Define in this problem, find the eigenvalues and eigenvectors of the Leslie matrix for A equal to 0 to 1, 0. 0.5, 0, 0, 0, 0.3 and 0. Here A1J is the birth rate. Three age groups, that is 2 and 3. AI, AI minus 1 survival rates. So from this ideate, compute eigenvalues to find the dominant growth rate. And second thing is find the corresponding eigenvector to determine the stable edge distribution. Third thing is consider a numerical for large matrix but use direction computation for this 3 by 3 matrix. Interrupt result to guide conservation. Focus on age group with high influence on growth. Prototype. Step 1. From the characteristic equation, determined the determinant of A minus lambda I equal to 0. To compute A minus lambda I. So determinant of A minus lambda I is equal to 0. We get lambda values. The lambda values are 0.5 and 0.858. So we get the lambda values from the lambda values most nearest to positive number 0.858. So in this lambda value we find the eigenvector. So the eigenvectors are 4.91, 2.86 and 1, which is the age distribution, stable age distribution. Lambda value is the eigenvalue. So the juvenile approximate to 54.8%, adult age 31.9%, and elderly is more or less similar to 11.2%. Inside, juveniles dominate the stable population. The suggest focus on juvenile survival for conservation. Application to inform strategies to increase survival rates. So testing, that is verification, is lambda, put lambda equal to 0.858, and vectors are 4.91, 2.86, and 1. So av equal to 6.78, 2.455, 0.858. So the result are approximate due to rounding, but confirm v1 is an eigenvector for lambda equal to 0.858. For the in summary, for the Leslie matrix, find eigenvalue and eigenvector. So the population growth will be calculated in this way. Okay, thank you.